Welcome to Learnpedia, JEE NEET coaching at your own pace as per your schedule. Now take a look at this actual JEE question and see if you can answer that. If you think you got the answer, post it in the comment section below. To understand the concept behind this question, go ahead and watch this video.
Now we will discuss the calculation of nearest neighboring atoms. That means in a unit cell they may present in simple crystal lattice or body centered cubic crystal lattice or sometimes face centered cubic crystal lattice. Here take a simple example, simple or primitive crystal lattice. In this case what happens? Atoms or ions present at only corners. So the distance between adjacent two atoms is nothing but the edge length. This would be the edge length. Half of the edge length gives the neighboring atom to the each atom in simple cubic crystal. But in the case of face centered, some atoms are present at the face. So the distance will reduce now because this is the face diagonal. So the distance between the neighboring atoms is further decreased. So the neighboring atom distances is decreases from simple cubic to face centered cubic crystal lattice. And if the atom is present at body center, then the distance is increases. This is the body diagonal. The distance between the two neighboring atoms like this. So with the varies of the structure of the crystal lattice present in the crystal, the distance between the two neighboring atoms, which generally denoted by D, is varies. That you can see for each system. That is, first one is simple cube. Here in a simple cubic crystal system, all atoms are present at the corners. Now this is the one corner and it has one atom, and this is another corner, another atom, another corner. Like this, in the 8 corners, 8 atoms are present. And this atom, this would be the radius of the atom R. And this is a radius of another atom R. And the distance between the two atoms is denoted with R. In general, we already know that this is the total edge length of the unit cell A. And the distance between neighboring atoms or in generally adjacent atoms in simple cube is A by 2. So we know that A equal to 2R in the simple cubic system and A by 2 is R. The distance between the adjacent atoms in the simple cubic is R. In generally this is denoted with D. That you can see in this animation. This is the unit cell which has 8 atoms at the corner, which is represented with a simple cubic crystal lattice. In this is the 2 atoms which are present at the 2 corners, and the edge length is A, and the radius of each atom is R, and the A is represented with 2R. Now the distance between the two neighboring atoms should be A by 2, that is R. What is the neighboring distance of atoms in the face centered cubic crystal system? As we know that for a face centered cubic crystal system, the atoms are present at corners as well as faces. So the distance between the two neighboring atoms is decreases. Take a simple example. This is the face and these two are the corners. Now if you want to represent the distance between the neighboring atoms, means this would be the distance between the neighboring atoms. We know that this is a edge length A and this is also edge length A. According to Pythagoras, the distance of the face diagonal is root 2A, which is equal to 4R. So the distance between the two neighboring atoms should be half of the distance of diagonal. So the distance between the two neighboring atoms, that is D, equal to root 2A by 2. In generally root 2A in the face diagonal is equal to 4R by 2, that is 2R, that you can see in this animation. This is the unit cell which has a corners and faces are occupied by the atoms. This is the face diagonal, and these 3 atoms are occupies the face diagonal. One is at faces and another one is corner and another corner. Edge length is A here. And the diagonal of the unit cell is root 2a, which is equal to 4r. This would give the clear expression for you. And the distance between the neighboring atoms is nothing but half of the distance of the diagonal, that is root 2a by 2, that is 4r by 2, that is 2r. Next one, the distance between the two nearest atoms in the body centered cubic crystal. This is also same as it has 8 corners as well as one body centered unit which is present at the body center. And as we know that these two are the edges, and this would be the face center, that is root 2a, and this would be the body center, this is root 3a. This root 3a means one atom is present at the body center, another one is another corner, and it is another corner. This is the distance 4r, which is equal to root 3a. So the neighboring distance is, this would be the neighboring distance between the two atoms, that is equal to root 3a by 2, that you can see in this picture. This is the body centered cubic crystal lattice which has atoms at corners as well as body centered. This is the body diagonal. The atoms are arranged in this way in the body centered, and these are the edge lengths of the body centered cubic crystal lattice that you can see here. And this would be the face centered diagonal which has equal to root 2a according to Pythagoras theory. So when you use this triangle, this would be the another triangle that you can see in the red color. The triangle has two faces, which is one is edge length a and another one is face diagonal root 2a. According to Pythagoras, the diagonal of the triangle would be root 3a. This root 3a is equal to radius of the atoms, which is equal to 4r. So neighboring distance between the two atoms is root 3a by 2, that you can see here.
I hope you can now answer the question. Take a look at the solution now. Hit the bell icon below and subscribe to our LearnPedia channel to learn more through such interesting videos. LearnPedia's JEE and NEET prep tools contain over 4,000 videos and over 20,000 questions. They are accessible online on our website and also offline through an SD card or a pen drive. To buy now, visit www.learnpedia.in. You can also try a free demo of a product before purchase.